Hello and welcome to this channel. So we're going to solve the integral of 1 over e raised to the power of x plus 1 all with respect to x. So in order to solve this integral, let's make a u substitution. Let's say that u is going to be equals to e raised to the power of x plus 1. So what do we get when we differentiate u with respect to x? Let's do it. If we differentiate u with respect to x, which is du over dx, derivative of e raised to the power of x is still e raised to the power of x. We're going to be writing e raised to the power of x. And making dx the subject of formula, we're going to be having to be equals to du over e raised to the power of x. So now that we have the x over here and we have made the u substitution, let's put all this into this original equation we have here. We write this is going to turn to the integral of 1 over e raised to the power of x plus 1 is then going to be equals to u instead of just writing e raised to the power of x plus 1. And dx as you're seeing here is equals to du over e raised to the power of x. So multiplied by du over e raised to the power of x. But wait, there is an anomaly here. There's a big problem. We can never have e raised to the power of x when we're differentiating with respect to u, except if we assume this is a constant. But we're not going to do that. Instead, we're going to look at this equation. We're then going to see that we had that u was equals to e raised to the power of x plus 1. So e raised to the power of x over here is then going to be equals to u minus 1. Now if you're bringing 1 to this other side of the equation, so we're going to be having the integral of 1 over u minus 1 multiplied by du. We can't just integrate it like this. We need to decompose it into partial fractions. So let's say we have a fraction like 1 over u minus 1. We're going to assume that there's going to be an a over here where a is just a constant. It can be anything. A over u plus b. B is also a constant. It could be anything, any number at all. U minus 1. So let's use a method here. We have 1. So we're going to write 1 is equals to a multiplied by u minus 1. We're going to be having a u minus 1 plus, since there's a positive sign here, b multiplied by u, you're going to be having b u. So expanding this, you're going to be having 1 is going to be equals to au minus a plus b u. So now let's work with coefficients. Now we see that the coefficients of u on this side of this equation is 0 because there is no u at all. So we're going to write in 0. This is for the coefficients of u. Coefficients of u. So 0 is going to be equals to, now let's look at the right hand side of the equation. Are we seeing any coefficients of u? Yes, a is a coefficient of u. So we're going to be having a. Are we seeing any other coefficients of u? Yes, b is also a coefficient of u. So we're going to write in a plus b. Now let's go to the next power. The next power is the power without u at all. That is the one that's just a constant, which is just 1. So now we have that 1 is equals to, let's go to the right hand side of the equation. Are we seeing anything without any power over there? Yes, we're seeing negative a. So 1 is going to be equals to negative a. So we've gotten something already here. We have that 1 is equals to negative a, meaning that b, we have the 1 is equals to negative a already. So meaning that a is going to be equals to negative 1. A is going to be equals to negative 1. And if a is equals to negative 1, according to this, we're going to have 0 is equals to negative 1 plus b. Meaning that b is going to be equals to 1. So we have a to be equals to negative 1 and we have b to be equals to 1. So let's substitute the value of a and the value of b into this. So we're going to be having a is equals to minus 1. So we're going to be having minus 1 over u. And b is equals to 1. So we're going to be having plus 1 over u minus 1. So we just successfully decomposed this. So we're going to be having the integral of this with respect to u. So now, getting the integral of minus 1 over u. The integral of minus 1 over u, we know that whenever we have something like the integral of 1 over u, is always equals to ln u. And let's say we have minus 1 over u. It's going to be equals to, the minus 1 is going to come behind the integral sign because it is acting like a constant, acting like negative 1. So it's going to come behind the constant, so we're going to be having negative ln u. And why is this so? So if you find the derivative of this using differentiation techniques, you know that the derivative of ln u is going to be equals to the derivative of what is inside, which is equals to 1 all over what is actually inside. And this is exactly what we have here. So whenever you see an equation of this form, you know that the integral is always going to be equals to ln u. Let's say we had 1 over u minus 1. We're going to see something similar as well. We know that the integral of this is also going to be equals to ln u minus 1, because the derivative of u minus 1 is going to be equals to what's the derivative of what is actually inside, and derivative of u minus 1 is equals to 0, and derivative of u is equals to 1. So it's going to be equals to 1 over what is actually inside, which is equals to u minus 1. So differentiation is the opposite of integration. So this is going to be equals to negative ln u plus ln u minus 1 plus c. So we're very close to the final answer. So left for us to do over here is to make the substitution back again. And remember, we had that u was equals to e raised to the power of x plus 1. So we're going to be having negative ln e raised to the power of x plus 1 plus ln. Remember, we had that u was equals to e raised to the power of x plus 1. And doing this, let's substitute it. We're going to be having e raised to the power of x plus 1 minus 1. So we're just going to be having e raised to the power of x. So ln e raised to the power of x plus c. So this is an answer, but we could continue this. Where x, but we aren't done yet. So we're going to rewrite this. But wait, let's start with this one over here. So we have ln e raised to the power of x. So we know that ln is the inverse of e, meaning that you're both going to cancel and we're going to be left with x according to logarithm. Because this ln is a natural log, which is very similar to log. And we can just bring this x over here to this side. Therefore, we're going to be having x multiplied by 1, which is equals to x. So we're going to be having x minus ln e raised to the power of x plus 1 plus c. So this is the final answer.